Alright folks, gather around for a trip back in time. Imagine the early 19th century when astronomers were mapping out our solar system and making groundbreaking discoveries. One of the most intriguing stories from this era involves a mysterious, hypothetical planet called Vulcan. Vulcan was thought to exist in an orbit between Mercury and the Sun. The idea of Vulcan dates back to the 17th century, but it gained significant traction thanks to the French mathematician Urbain Le Verrier. Le Verrier had already made a name for himself by predicting the existence of Neptune using disturbances in the orbit of Uranus. So, when he noticed peculiarities in Mercury's orbit, he applied the same logic. In 1859, Le Verrier proposed that these orbital anomalies could be explained by the gravitational influence of another nearby planet, or a series of asteroids. He called this new planet Vulcan. Around the same time, a French amateur astronomer reported observing an object passing in front of the Sun. Le Verrier was convinced that Vulcan had finally been discovered. The scientific community buzzed with excitement, and many searches for Vulcan were conducted over the following decades. Some astronomers even claimed to have spotted it. However, despite numerous efforts, no conclusive evidence of Vulcan's existence ever emerged. So, what happened? Why couldn't anyone find Vulcan? The answer lies in a groundbreaking theory that came a few decades later. In 1915, Albert Einstein introduced his theory of general relativity, which fundamentally changed our understanding of gravity and motion. According to Einstein's theory, the peculiarities in Mercury's orbit could be explained by the curvature of spacetime caused by the Sun's mass. This revelation rendered the need for Vulcan obsolete. Vulcan, the elusive planet that had captivated astronomers for decades, turned out to be a product of our incomplete understanding of the universe. So, did Vulcan ever exist? The answer is no, but its story is a fascinating chapter in the history of astronomy. But what is stopping us to get into the ancient details? In 1840, François Arago, the esteemed director of the Paris Observatory, proposed that mathematician Urbain Le Verrier take on the challenge of studying Mercury's perplexing orbit around the Sun. The aim was to construct a model grounded in Sir Isaac Newton's laws of motion and gravitation. By 1843, Le Verrier had published a provisional theory on Mercury's motion, followed by a more detailed presentation in 1845. His predictions were put to the test during a transit of Mercury in 1848. However, the observations didn't align with his theoretical predictions, marking the beginning of a deeper investigation. Undeterred by the initial discrepancies, Le Verrier continued his meticulous work. In 1859, he published an even more rigorous study based on numerous meridian observations of Mercury and 14 transits. He calculated that it might be another planet of Mercury's size, or more plausibly, an unknown asteroid belt close to the Sun. After all, he had successfully predicted the existence of Neptune in 1846 using similar techniques. This new prediction ignited a fervor among astronomers, intensifying the search for the elusive Vulcan. Our journey through the mystery of Vulcan takes a dramatic turn with the story of a claimed discovery that shook the astronomical community. On December 22, 1859, Urbain Le Verrier received an intriguing letter from an amateur astronomer named Lescarbault. The letter detailed an observation of a transit of the hypothetical planet Vulcan on March 26 of that year. Eager to investigate, Le Verrier boarded a train to the village of Orgères-en-Beauce, about 70 kilometers southwest of Paris, to visit Lescarbault's homemade observatory. Le Verrier arrived unannounced and immediately began questioning Lescarbault. The amateur astronomer described how he had observed a small black dot moving across the face of the Sun. Initially, he thought it resembled the transit of Mercury he had seen in 1845. Using rudimentary equipment, including an old clock and a pendulum used for taking patients' pulses, Lescarbault estimated the transit's duration to be 1 hour, 17 minutes, and 9 seconds. On January 2, 1860, Le Verrier announced the discovery of the new planet, proposing the mythological name Vulcan at a meeting of the Académie des Sciences in Paris. Lescarbault was awarded the Légion d'honneur and invited to present his findings to numerous learned societies. However, not everyone was convinced. Emmanuel Liais, a prominent French astronomer working in Rio de Janeiro at the time, claimed to have been observing the Sun with a telescope twice as powerful as Lescarbault's. Liais asserted that he saw no such transit, casting doubt on the veracity of Lescarbault's discovery. Le Verrier, undeterred, calculated Vulcan's supposed orbit. According to his computations, Vulcan revolved around the Sun in a nearly circular orbit at a distance of 21 million kilometers, with a period of revolution of 19 days and 17 hours. The orbit was inclined to the ecliptic by 12 degrees and 10 minutes, and Vulcan's greatest elongation from the Sun was 8 degrees. Was it a genuine observation or a case of mistaken identity? Our cosmic investigation into the elusive planet Vulcan continues with a series of intriguing attempts to confirm its existence. The astronomical community was abuzz with numerous reports from amateur astronomers who claimed to have seen unexplained transits across the Sun. Shortly after 8 a.m. on January 29, 1860, Farr Russell and 3 other observers in London reported witnessing an alleged transit of an intramercurial planet. Around the same time, an American observer named Richard Covington claimed to have seen a well-defined black spot progress across the Sun's disk while stationed in Washington Territory. Despite these tantalizing reports, no observations of Vulcan were made in 1861. However, on the morning of March 20, 1862, between 8 a.m. and 9 a.m. Greenwich time, another amateur astronomer, Mr. Lummis of Manchester, England, observed a transit. His colleague, whom he alerted, also confirmed the event. Based on these two men's reports, French astronomers Benjamin Valz and Rodolphe Radeau independently calculated the object's supposed orbital period, with Valz deriving a figure of 17 days and 13 hours, and Radeau a figure of 19 days and 22 hours. The pursuit of Vulcan continued with another unexpected transit observed by French astronomer Aristide Coumbari from Istanbul, Turkey on May 8, 1865. However, between 1866 and 1878, no reliable observations of the hypothetical planet were recorded. Then, during the total solar eclipse of July 29, 1878, 2 experienced astronomers, Professor James Craig Watson and Lewis Swift, both claimed to have seen a Vulcan-type planet close to the Sun. Watson, observing from Separation Point, Wyoming, placed the planet about 2.5 degrees southwest of the Sun, and estimated its magnitude at 4.5. Swift, observing from near Denver, Colorado, saw what he believed to be an intramercurial planet about 3 degrees southwest of the Sun, estimating its brightness to be similar to Theta Cancri, a 5th magnitude star visible during totality. Both described the color of their hypothetical intramercurial planet as red. Despite their reputations as excellent observers, the coordinates provided by Watson and Swift did not match known stars or each other, generating controversy. The search for Vulcan continued during total solar eclipses in the following years: 1883, 1887, 1889, 1900, 1901, 1905, and 1908. The search for Vulcan, despite the fervent efforts of many dedicated astronomers, ultimately met its end with a groundbreaking shift in scientific understanding. In 1915, Albert Einstein introduced his theory of general relativity, which revolutionized the way we perceive gravity. Unlike classical mechanics, Einstein's theory accounted for the peculiarities observed in Mercury's orbit without the need for a hypothetical planet. Einstein proposed that the mass of the Sun caused a curvature in space-time, affecting Mercury's orbit and causing its perihelion to advance by 43 arcseconds per century, exactly the amount observed. This new understanding rendered the existence of Vulcan unnecessary. The empirical verification of Einstein's theory came during the solar eclipse of May 29, 1919. Photographs taken during the eclipse confirmed that starlight was indeed bending around the Sun, validating the curvature of space-time. With this confirmation, astronomers quickly accepted that a large planet inside Mercury's orbit could not exist based on the corrected equations of gravity. Today, while the International Astronomical Union has reserved the name Vulcan for the hypothetical planet, it remains a relic of a fascinating chapter in astronomical history. The term also extends to the hypothetical Vulcanoids, a population of asteroids that might exist within Mercury's orbit. However, despite advanced Earth and space-based telescopes and the NASA Parker Solar Probe, no such asteroids have been detected. In conclusion, the mystery of Vulcan, the hypothetical planet, has fascinated astronomers and scientists for centuries. Despite numerous attempts to confirm its existence, the planet remained elusive. It was only with the advent of Einstein's theory of general relativity that the discrepancies in Mercury's orbit were explained, leading to the disapproval of Vulcan's existence.